Alright, so let's now talk about how we will deal with probability theory. Important sort of concept is a simple event. Alright, so you can think of a simple event is an event that cannot be subdivided, that cannot be broken down into smaller events. Right? A coin toss is one of those. So a head is a simple event. So a head on a coin toss. Tail on a coin toss, right, cannot be subdivided. If you roll a die, you have 6 faces. 1, 2, 3, 4, 5, 6. Right? You take one of them, say a 2 is a simple event. Right? You cannot break it down anymore. So 2 on a die. Sort of the other end of that spectrum of simple event is compound event. And a compound event is an event that can be broken. All right, so even number on a die is a compound event. It's an event that can be broken down into 3, in this case, simple events. Of course, when we talk about compound versus simple, but in particular simple, we assume that we have what we call a discrete number of events. That is, the events are somehow lumpy. Right? You can put them in little bundles which are can't be divided. All right. So, for instance, if you're waiting for a particular phone call from a person and they say, "I'm going to call sometime during business hours today," the probability of that person calling before noon, all right, the event before noon is not a simple event, it's a compound event, but time cannot be broken down into simple events. All right, because time is continuous, it's not lumpy. Okay, so we have discrete versus continuous, and when we talk about simple events, we're normally talking about discrete situations where we have a limited number of events, and we can think of that like integers, all right, and continuous like real numbers on the number system. Alright, but in any case, we define basic probability. Say if we have an event I, just some sort of event, simple or compound, basic probability theory rules tell us that that probability must be between 0 and 1. It can be 0, it can be 1, but it cannot be further. This might sound very trivial, but it's amazing how many students in an exam, when I ask for what is the probability of, will give me a negative number or a number greater than 1. Okay, so once that happens, that's wrong. The next rule of basic probability theory is that if you have a set of simple events and you add them all up, alright, so let's say you have n simple events, you add up the probabilities for these simple events and they add up to 1. Okay, it's difficult to talk about that in terms of compound, but the same thing will apply. Okay, in a compound event, you might do it in terms of integrals that you may remember from calculus, but essentially the same thing is true. If you get all the events, all right, together, even if they're infinitely small, like in time, right, the probability that that call is going to come today, if they say it's going to come, is 100%. We just don't know when, so we could give intervals a probability, right? So the probability that the call is coming between 11 and 12, we might say there's 60% chance. Okay. All right, so let's for quite a while actually, let's talk about discrete events. And let's talk about our counting rules that work with discrete events. Alright, so let's talk about rolling a die. What's the probability of a 2 on one roll? Well, presumably you all know the answer, but the probability, and I'll write it like this, 2 occurring is 1/6. Why is it 1/6? Well, there is one 2-face on the die divided by 6 total number of faces. Alright, and we assume, of course, that each face on the die has the same probability of occurring, so the probability is 1/6. Alright, so that's a simple counting rule. So if we talk about the probability of an even number on one roll, right, well, there are 3 even numbers divided by 6 possible, so 3/6 or 1/2. Or the probability of getting a number on the face of the die greater than or equal to 2, well, it's 5/6, because this event greater than or equal to 2, you could have a 2, 3, 4, 5, or 6. Alright, so 1, 2, 3, 4, 5 ways of satisfying the condition greater than a 2. Alright, 6 possible ways, so the probability is 5/6. Alright, so this leads us to the first basic rule in probabilities, the addition rule. Let's say that we have 2 events, A and B, and the addition rule goes as follows. The probability of A or B occurring is the probability of A plus the probability of B minus the probability of A and B. Okay, and now it's best to describe what that means with a simple example. Alright, so let's say again the die situation. Let's say we have 2 events. A is the even number showing up, and B is the number on the die greater than 2. Not the example that I had before, greater than or equal to 2, but greater than 2. Alright, so these events are 2, 4, and 6 for A, and greater than 2 would be 3, 4, 5, 6. Okay. Alright, so the probability of A in this example, alright, 3 out of 6, 1/2. We have 3 possibilities, 2, 4, 6. Okay. Probability of B in this example, alright, we have 1, 2, 3, 4 possibilities out of 6. This is whatever, 2/3. The exact simplest answer is not that important here. Alright, so what's the event for the probability A or B? Okay. Well, we've got to figure out what A or B means. So we want a face turning up so that we satisfy either event A or event B. And that occurs when we can have a 2, 4, or 6, or 2, sorry, not a 2, or a 3, or a 4, or a 5, or a 6. So to make this nicer looking, we have double counting going on here. The 4s twice, the 6s twice, so we could have either a 2 or a 3. Sorry, I should have knocked off both 4s and both 6s, or a 6. Okay, so when I did these events before, even number 2, 4, 6, I meant a 2 or a 4 or a 6. Alright, so just by using the counting rule, probability of A or B is we have 2, 3, 4, 5, alright, or 6, sorry, and so it's 1, 2, 3, 4, 5 possible outcomes divided by 6, so that's 5/6.